Okay. What we've got is algebra, recognizing and collecting like terms. So this is important to understand when you're adding and subtracting in algebra, but we'll come to that later on. When you're recognizing and collecting like terms, you have to treat it like a face recognition software. If two things are not exactly the same, okay, we'll get to the things later. If two things are not exactly the same, they're not like terms, no matter how closely looking they are. Okay, so some of the letters I'm going to be using, don't worry, we'll get to that in terms of how you get those kind of letters together. Okay, all we're dealing with now is just recognizing and collecting the like terms, and by collecting I mean just gathering them and putting them together. Okay, so if I think of a letter A and A, they're both like terms. Okay, now when I say they're like terms, I'm dealing with the letters. That's all I look at. They're exactly the same. This is an A, this is an A, so they're like terms. Okay, if I say 2A and 3A, you might be thinking, but he said exactly the same. Are they like terms? Yes, they are. Because what we're looking at, or what we're comparing to say if they're like terms or not, is not the number, it's the letters behind. If the letters look exactly the same, then they're like terms. Okay? Now, 2A, 5B, these two are not like terms because the letters at the end are not exactly the same. Okay? Now, if we move on to more complicated letters, so if I said AB, okay, and BA, you might say, well, no, they're not like terms, but they are, because the letter at the end, there's an A, there's an A, there's a B, there's a B, okay, and they look exactly the same. The only thing is their position is different, okay. Now, if I said X and X squared, are they like terms? No, because yes, there's an X here and there's an X here, but the powers are different. Remember I said the letters have to be exactly the same. Okay? So they're not like terms. Once again, if we have 2xy and 4yx, now remember, we pick like terms based on the end letters. So there's an x with no power sharing, there's an x with no power sharing. There's a y with no power sharing, there's a y with no power sharing. So these two are definitely like terms. Okay? Now, for the complicated batch, if I said a squared b and b a squared, are these like terms? Let's compare. It has an a with a squared, okay, and it has an a with a squared. It has a b without a power sharing, it has a b without a power sharing. They are like terms. Okay, now if I said 3ab squared and 7, now let's begin to compare. The a here has no power sharing. The a with the 7 has a power of 2 sharing. So with that, they're definitely not like terms. And then when you come to the B has a power of 2. The B here has a power of 1. That's the power that doesn't show. So they're definitely not like terms. Okay? So the key to recognizing and collecting like terms, okay, is all about comparing the end letters. If they're exactly the same, they're like terms. Okay, now looking at this list in boxes, we want to gather the like terms. Okay, so we have 2x cubed here. So the x has a power of 3 behind it. Is there any other one that looks the same as that one? So we'll have that one. I'll put a line under it, just one line. That's not like it. That's not like it. That's not like it. That is like it. Not because of the minus or the 5. Remember, we're not comparing the numbers. We're comparing the letters at the back. The combination of letters at the back if they look exactly the same. So definitely they're exactly the same. So they're connected. Okay? So I put one line below. We go to the next one. It's got an x to the power of 2 and a y behind it. Let's check. Remember, we're not comparing the numbers, we're comparing the combination of letters behind. This is x with no power. This one has a power of 2. So first of all, based on that, we can rule it out. Doesn't have an x, we can rule that out. Keep moving. This one has a y to the power of 2, that has a y to the power of 1. Nope. With this one, it has a y with no power showing. This has a y with no power showing. Has x to the power of 2, has x to the power of 2. So they're like terms. Okay. This one, x to the power of 1, because there's no power showing, and y to the power of 2. That's not it. That one has y to the power of 2 and has x to the power of 1. Okay, so they're like terms. And finally, we need one that has y to the power of 3. Okay, so the like terms from our arrangement, we gather them. So I put 2x cubed next to its like term. That's minus 5x cubed. I put 6x squared y next to its like term, 15yx squared, and 6xy squared. I put it next to its like term, minus 15y squared x. Now remember, we're comparing the letters if they're exactly the same. Okay? They don't have to have the same arrangement. Each letter just has to be the same. There's an x, there's an x. There's a y to the power of 2, there's a y to the power of 2. Okay? And then finally, 2y cubed and its like term minus 5y cubed. Now, make sure to take the time to study each and every one of the end letter combinations, okay? So you can easily recognize which one is exactly the same, okay? And that's how you collect like terms. The like terms is based on the letters at the back end of the number, okay? If the letters look the same, then they're like terms, okay? And that's the key to it. Watch this video as many times as possible and make sure you understand it. Okay? Thank you very much. You've been listening to the Math Done, and until next time.